Hello friend, today's question is we are given a general term of a sequence that is n cube over minus 1 to the power n, and we are going to find the sum to nth term. So we have already discussed how to find the general sum for nth term of the sequence, which is in the form of f of n divided by x to the n. So we can use this method given by this formula. If you haven't seen my video, you can look the link in the description. Now we will use the same method to find the general sum for nth term. Here this sequence is in the same form, but the value of x here is -1. So this can be taken as an alternating series. So let's proceed. First we find the terms of the sequences by placing n equals 1, 2 and 3 and so on. But how many terms do we need? Just look at the highest degree of n in the numerator, that is 3. So we actually need only 4 terms. So we may not go above the 4th term. So the sum can be represented like this. Then at the first step, take out the numerators and find the consecutive differences, that is 1, 8, 27 and 64. Find the consecutive differences between them, like 8 minus 1 is 7 and so on. And finally you'll reach one number at the end. Then extract the diagonal elements only, that is 1, 7, 12 and 6. Then we use the principle to find the sum to infinity. To get this number, just put these numbers in the numerator, and here in the denominator we have got -1, so subtract 1, it will give us -2, so put it in the denominator like this, and with increasing power 1, 2, 3, 4, same as that of the question, but subtracting 1 from the denominator. So this will give the value of 1/8. In the same process, forget the number 1 and repeat the process. 7, 12 and 6 in the numerator, and in the denominator raised by the power of -2 in increasing order. This will give us -5/4. Again forget 1 and 7, repeat the process, and the value will be -9/2, and again repeat the process for last number 6, and that will give us -3. Let's say these constants as a0, a1, a2 and a3. Then multiply with proper combinations 0, 1, 2 and 3. Then the sum will be given by this relation. 1/8 will be this number, minus 1 by -1 to the n will come here, and these numbers are nothing but the addition of these all numbers, like 1/8 times cn0 plus -5/4 times cn1 plus -9/2 times cn2 minus 3 times cn3. These are nothing but the binomial coefficients represented by cn, 0 and so on. Then we just simplify these terms and we will get this result. So the sum of nth term of the sequence is given by this rule. So let's check the result. The sum to first term is got by putting s1 equals 1 minus 1. The sum to second term can be got by adding these two terms, which is 7. The sum to third term will be found by adding these three terms, which is -20, and in similar fashion the sum to fourth term is 44. And by using the rule that we just got, we can check by plugging n equals 1 will give -1, which is correct. Plugging n equals 2 will get 7. Plugging 3 will get -20. Plugging 4 will get 44. So which is correct. So you can use this rule to find the nth term of any alternating sequences. So thanks for watching.